Addition is another type of reaction that can occur in organic compounds. When we have an addition reaction occur, we see that we add a molecule. In this case, we're representing it by AX, and it adds what we say across the double bond. Notice, as the addition occurs, we start as our reactant has a double bond between two carbon atoms, and in the product, that double bond has been changed to a single bond, but we know that carbon must have 4 bonds, and so the fourth bond that was the kind of the double bond is now been replaced with an A on one of the atoms and an X on the other. So we take it, the double bond goes away, and we add the molecule across that double bond. Even if there were more carbon atoms beyond these two, if they were all single bonds, the addition is not going to occur elsewhere in the molecule. It will always occur where we have the carbons involved in the double bond. One of the atoms adds to one carbon, and the other part of the molecule adds to the other carbon. So we see that the A is added to one and the X is added to the other. Now, for this, there are multiple options for this AX molecule. We can have things like H2, so hydrogen, chlorine, so our other halogens, that includes fluorine, bromine, and iodine. We can have HX, where H is a halogen, so something like HCl or HBr. Or we can have water adding across the double bond. Notice that when we have water, it's not going to add as H2 and O, it's going to add as an H and an OH. So when we look at our AX, we could say that the H is like our A part and the OH is our X. So instead of seeing the H and H, if we were adding hydrogen, we would see that we have an H here and an OH on this side of the molecule. So whenever we're adding water, we're always going to see it adds as an H and an OH group. So looking at a specific example, hydrogenation is the addition of H2 to an alkene. Notice in the name we have our hydrogen and we have our ation. And ation means to add. Hydrogenation, therefore, is adding hydrogen. And what we see is that our double bond goes away from our reactants to our products. And we see that our hydrogen was added to the two carbons that were involved in the double bond. So now we've added an additional hydrogen to each of those carbon atoms. Now notice here it says there's a nickel catalyst. Most organic reactions have a catalyst, need UV light, have some other condition which makes it happen. We are going to always assume that the conditions are correct for the reaction to occur. Because without this catalyst the reaction doesn't happen, but we're not going to get into those details. If we show a reaction where we're adding hydrogen, we can assume that the conditions, whether it be temperature, catalyst, UV light, are all present and it's correct for the reaction to happen. So here's an example with hydration, and so we're more familiar with her term dehydration, where we don't have enough water. So hydration, we have hydra, which is water, and ation, which is our adding, so we're adding water. Again, it's going to add to the double bond across that double bond. So we break up our water molecule as an H and an OH. We see that we add the H to one of the carbon atoms, and we add the OH to the other carbon atom. Again, the species that add always add to the carbons that were involved in the double bond. So let's look at an example. What is the product when 2-butene, which is pictured here, is hydrated? So remember, hydration is the addition of a water molecule. And when we add a water molecule, we're adding it as H and OH. And so we have to find where the double bond is. So the carbons that are involved in the double bond are here and here. So we know that's where the addition is going to happen, which means C is not an option because the addition of that OH does not occur at the carbons involved in the double bond. When we look at our adding the OH and H, notice that we're not showing the H because remember that we have implied hydrogens in our skeletal structure, so even if it doesn't explicitly show the H, that doesn't mean that the hydrogen hasn't been added. And we look at B and we see that we have an OH and an H added across that double bond. So that's our correct answer. So when we look at what's wrong with A, what we see is that we still have the double bond present. And when we have an addition, we're going to see that the double bond is changed to a single bond, and we add the substituent groups to it.